Okay. The title of my presentation is Pyrolysis and the Properties of Endothermal Fuel in microchannels at temperature up to 750 degrees centigrade. I came from Xi'an Jiaotong University, and the key points of keywords of this paper is endothermal fuel. That means fuel used in the aircraft is not only a propellant, but also a coolant. We use this fuel to cool the engine. And after fuel was studied and made, fabricated, before it is used in the industry, we used to know the property and of thermodynamic property. So because the application is very high temperature, so there are no commercial devices can measure the thermodynamic, high temperature thermodynamic property. So we need to find out the method and the devices to obtain this basic data. There are four parts of in my presentation. First is the motivation. Hydrocarbon fuels used in many applications in rocket, in aeroplane, and in new air-breathing hypersonic vehicles. During this process, hydrocarbon fuel used not only a propellant, but also a coolant. We use this fuel to protect the combustion chamber. So we have many microchannels around the engine. So before the fuel can be used in engineering, we need to know the thermodynamic properties to design the cooling structure, and also there are pyrolysis and chemical reactions take place in the channel during the cooling process. We need to know this process to prevent the cooking and choking. The channel was choked. Because there are many channels around the combustion channel, we need to study the fuel flow in the microchannel in many parallel channels. If we didn't design the cooling structure properly, there are problem may appear. For example, in this is multiple channel, many parallel channel, and the heat transfer deteriorates. Critical heat flux take place in the upper portion. Most fluid flow in the channel in the upper portion. So this part will be the water temperature will rise very high, and the metal may be melt. So this process must be avoided in the engineering. Also, during the fuels flow inside the microchannel, many chemical reaction may take place, and cork may form, can be appear in the wall, and this carbon deposition will affect the heat transfer and may affect the cooling of the wall, and the wall temperature may be very high. So we need to study the heat transfer and flow process of fuel in the microchannel, and also we need to study the chemical process during this process, during the fuel flow. Because since this new hypersonic vehicle is a very new technology. The efficiency of the engine is very high, so we only use very few fuel can get the engine work. So we need to the work must be worked as coolant, and the temperature may be up to 800 degrees centigrade. But there are very few high temperature thermodynamic properties. We have found that 186 papers was found, but 165 paper was about the thermodynamic property at atmosphere pressure around room temperature. High temperature property is very weak. To use hydrocarbon fuel efficiently and safely, we need to study fluid flow characters such as pressure drop, flow instability, and heat transfer characteristics such as supercritical heat transfer, effective of chemical reaction and caulking on heat transfer. And we need to get heat transfer correlation for the purpose of design of the cooling structure. We also need to study the caulking property, such as cooking evaluation method. And also we need to know the thermodynamic, physical, and chemical properties, such as heat sink, specific heat, density, viscosity, conductivity, and critical parameters. All these property is at a high temperature and supercritical pressure. In the past 10 years, we have developed many test facilities. For example, we have a series of setup for high flow rate and small flow rate. For this high flow rate test setup was used to study the flow control of entire engine. And for this test loop, we used to study the flow distribution of multi-channel flat plate. And for small channel, we used to study the heat transfer and fluid flow characteristics, such as heat transfer, critical heat flux, and pressure drop. For small test loop, we used to study thermodynamic property. The temperature, field temperature up to 750 degrees centigrade, and the heat flux up to 3 megawatts per square meter. We have completed studies in single channel, two parallel channels, and multi-channel plates with multi-channels with different structure. Here are some results of our typical results. For two parallel tubes, if we didn't take some special measures, when the heat flux is high enough, or the temperature, field temperature is high enough, more than 400 degrees centigrade, the flow rate of the two channel will depart greatly. Then this channel with very low flow rate will reach very high temperature. So this channel may have some problem. Also, because the cooling process have a very complicated chemical and phase change process, the pressure drop and mass flow rate correlation is very difficult, very complicated. If in parallel tube with common pressure difference, there are several flow rate may take place in different channels. This slide shows some condition for different design. If we designed not good enough, high temperature will take place in the upper part of plate, and this is the two sides high temperature. After we have very carefully designed the cooling structure, all the channel have uniform flow rate, then the temperature can get very high. For the evaluation coking property, we have developed many different methods. For this method, we can measure the coking condition online. This method can also apply in our engine.
3 minutes left, sir.
Also, we have developed some new some method to measure the density at a very high temperature. This is density for cyclone hexanes. Temperature up to 700 degrees centigrade for different pressure. And two capillary viscosity to measure the viscosity. Also, we develop a new device to measure the high temperature specific heat. Here are some data. And also critical parameter. Here are some papers published for heat transfer character of endothermal hydrocarbon fuel, and for thermal physical property for coking characteristics. We have a very have a series of test setup covered a very wide range of flow rates, and we have very we have experience to carry out some research up to 1,000 degrees. Thank you for your attention.